This is chapter 17, set E number 2. So we have an original box that has the numbers 1, 2, 3, 4, 5. And we're supposed to find the chance that between 8 and 32 tickets will be marked 5. Now notice this, the chance between like 8 and 32 tickets will be marked 5. That kind of all sounds to me like we're counting. Anytime you want to count, so we want to count, so it's saying we don't care if we have 1s or 2s or 3s or 4s, just it's either a 5 or not a 5. Anytime you're counting is there's only one thing you care about, you're going to want to make a new box. Okay, and so in this new box, you have a 1 for what you want, 0 for what you don't want. So we want to get things marked 5 for the 1. For everything else we don't care about, well, that would include 1, 2, 3, and 4, because those are the things we don't care about. So let's see how many we have. We will have 1 that's marked 1, and we will have 4 that are marked 0, because there are 4 things we didn't care about. So that's our new box. So let's find the average of our box. So the average of our box would be, we'd have to do 1, so there's 1, 1, plus 0, plus 0, plus 0, plus 0, all divided by our total of 5 tickets. Now, of course, you might notice you could do just 1 plus 4 zeros if you want to save a little bit of time putting in your calculator. Either way, you're going to get 0.2. And the SD for your box, well, we only have 2 values in there. These are the only SDs I make you come up with for your homework, because otherwise it would just take too long. But if there's only 2 values, we have this shortcut. So the SD, remember, is going to be our big number minus the small number times the square root of the fraction big times the fraction small. Okay, so our big number in the box is the 1, so we'll have 1 minus 0 times the square root. And the fraction of my big number, so there's 1 out of 5 total with the big number. And then for my small number, there were 4 out of 5. Now, you'll notice because of the commutative problems with multiplication, it doesn't really matter what order you put these in. Like, that's one of the problems where it doesn't really matter what order. If you accidentally switch up these, you'll get the same answer. It'll just be negative, and you should remember the SD, by definition, has to be positive. So you could just say, okay, well, I got negative. We could just switch it back to a positive. So if you mess up the order, it doesn't really hurt this formula as much as other formulas. But when you put that into your calculator, you should get 0.4. If you're having trouble getting this, make sure you have parentheses around everything inside the square root. Those parentheses are very important. Okay. So that's always the first step. There's a few steps to these problems, which does make it a little more difficult. You have to remember all the steps. But first step is find your average and SC of the box. Okay. Next step is you need to find the EV for the sum, because we want to do this 100 times. So we have to do like, okay, well, how is that 100 coming into play? So that's your expected value for the sum. What happens if we do it 100 times? So EV for your sum is number of draws times the average of the box. So we're drawing 100 times. We expect to get about 0.2 on average each time. So 100 times 0.2 should give me 20. So we'd expect to draw about 20 tickets that are marked to 5. Okay, now SE for your sum, well, that's going to be the square root of your number of draws times the SD of the box. So we'll do square root of 100 times the 0.4, which should give me, square root of 100 is 10, so that should give me about 4. Okay. So we expect to draw about 20 5s, give or take 4. So we know it's probably not going to be exactly 20. Like, it might be, but it's more likely to be. It might be a 19 or 21. Maybe one time it'll be 20, and the next time it might be 22. But it should be about 20, give or take 4. Okay. So that's what we do with the EV and SE. Now we get to add in the normal curve, because we know that the sum will be normally distributed as long as our sample size is big enough, which 100 would be big enough. So now we want to find the chance. So we want to find the chance that it's between 8 and 32. Okay. So anytime you want to find a chance, this is your normal curve. Well, for your normal curve, you have to find your z-values. So z is equal to your sum minus the expected value you were supposed to get for your sum over the standard error you were supposed to get for your sum. Now in this problem though, we do have two different values, so this does make it slightly more difficult. We're going to find two different z-values. So let's come over here and find two different z-values. So z-value number 1, you don't really have to put the 1, but I just put a 1 to remind myself I'm finding 2. Let's pick the first value of like 8. So we'll do 8 minus the expected value of 20 over the standard error of 4. So 8 minus 20 divided by 4. Make sure you have parentheses around the top. I get negative 3. For my second z-value, I'm going to pick this 32. So 32 minus the expected value of 20 over 4, again with those parentheses. So 32 minus 20 divided by 4 gives me positive 3. Now, I try to always draw a curve. Drawing a curve helps me figure things out better. Okay. So I have a z-value of 3 and a z-value of negative 3. And we want to find the chance we're between that. I probably didn't draw the scale because 3's and negative 3's, those should definitely be out in the tails, pretty far out there. Okay, now you open up your normal table. And we're going to look for those z-values of 3 and negative 3. Notice though, our table only gives us this area to the left on the table that I use. So if I say look up z equals 99.87, that's saying, okay, well here's 3 and the area all the way to the left is 99.87. And when I look up the negative 3, right here, that area to the left is 0.13%. But that's not the area in between. How do I find that area in between? Well, you say, well, if I take out and I subtract, so I subtract that 0.13, that would give me everything in between. Okay. So coming back, I draw a picture that looks kind of like this. I say from here all the way over, I know it's going to be 99.87. And from here over, I know that's going to be 0.13. So if I want the area in the middle, I subtract them. So I'll do 99.87 minus the 0.13, which gives me 99.74% is the area in the middle. Now, I find the textbook really rounds a lot. That's okay if your answer is not exactly the same because they are rounding a lot. It should just be something close to this.